Hello everyone, welcome back. Lesson 323 day 1 is today. We're going to learn how to multiply and divide rational expressions. Our content goals are pretty self-explanatory here, but we're going to learn how to multiply and divide rational expressions, and we're going to identify excluded values for rational expressions that have been multiplied or divided. Right, so let's get started here. Let's start by taking a walk down memory lane, and remember that back in the 4th or the 5th grade you guys learned all about fractions, and you learned how to perform operations on fractions that only had numbers in them. All right, so we're going to revisit that. We're going to start with something that you should already know, which is just how to straight up multiply two fractions. Right, so I've got a fraction 1/2, and I've got another fraction here 6/4, and we're going to multiply these things. Right, and the way that we multiply fractions is we just multiply straight across the top and straight across the bottom. So for instance, I can just do 1 times 6, and I would get 6 in the top of my new fraction. Right, then I do the same thing in the bottom. I do 2 times 4, and 2 times 4 is 8. Okay, so when I multiply these two fractions, this is what I get. I get 6/8, but this fraction can be reduced. All right, so we can reduce 6/8. It's got a common factor of 2, so this will reduce to 3/4. All right, so we'll do it one more time here. So we've got another set of two fractions here. So we're going to multiply 3/4 times 6/15. All right, so again, remember that we just multiply straight across the top and straight across the bottom. Another way to think about this, a little bit different than what we did last time, is to think of this new fraction as just essentially bridging the gap here. Right, so that multiplication, since we're just multiplying straight across the top and straight across the bottom, I can just bridge the gap and put a multiplication sign here and a multiplication sign here. All right, so we could say 3 times 6 and 4 times 15. All right, so I can just write it like that. And then I can kind of think about factoring, right? Because when we get to the algebraic expressions, we are going to have to factor. So for instance, a number like 6 could be split into two smaller numbers. So for instance, I would have the 3, and the 6 could split into 2 and 3, right? 2 times 3 is the same thing as 6. And then in the bottom, 4 could be rewritten as 2 times 2, and 15 could be rewritten as 5 times 3. And you might be wondering, why are we doing this? Why didn't we just do what we did last time? It seemed a lot easier. Well, the reason that I'm doing it this way is so that we can see the common factors in the top and the bottom, right? So when I got to this last part and I reduced the fraction over here, you might have gotten a little bit confused. But if I do it this way, it'll take care of all the reducing for me. All right, so notice that I have a common factor of 3 in the top and in the bottom, so I can cancel out one set of 3's, I can cancel out one set of 2's, and that's it, right? So if I'm looking in the top of the bottom, the only thing I have left in the top here is a 3, and in the bottom I have a 2 and a 5, so there's no more common factors to cancel out, so I just write this out. I have a 3 in the top, and then in the bottom I have 2 times 5, which is just 10. So this cannot be reduced anymore. Right, so this is already reduced for us, whereas with this one we just reduced at the end. We essentially did the same thing, but this is more closely related to what we're going to be doing with the algebraic expressions when we get there. All right, so that is multiplying fractions. Now, dividing fractions is very similar. Very similar. All right, it's not too hard. You have to remember to do your KFC. All right, so it's an acronym that stands for keep, flip, change. All right, you might want to make sure you write that down somewhere and remember that. So if I have two fractions like this and I'm dividing, right, so make sure you're paying attention to that sign in between the fractions. What we're going to do is we're going to keep the first fraction, right? So I'm going to write this out over here. I'm going to keep the first the way it is. So I'm just going to write down 2/5. We're going to flip the second fraction. So this is going to, instead of being 1/3, it's going to become 3/1. And then we're going to change the sign or the operation here to multiplication. Okay, so we went from this to this, and believe it or not, these two expressions are equivalent. That's why keep, flip, change works the way it does. All right, now what I'm going to do is I'm going to multiply just like we did up here, right? So I'm going to write this as 2 times 3 in the top and 5 times 1 in the bottom. So it's just like we bridge the gap. All right, and now what we're looking at here, I'm looking for common factors, and there is nothing that cancels, so I can just put these numbers together, right? 2 times 3 gives me 6, and 5 times 1 gives me 5. And that would be my final answer. Okay, so keep, flip, change, right? Keep the first, flip the second, change the multiplication, and then follow what we did up here for the multiplication steps. All right, let's try one more time. So we're going to keep the first. I'm just going to write out the first over here. I'm going to flip the second, so that becomes 14 over 3, and we're going to change the multiplication. All right, and then I'm going to bridge the gap. All right, so I'm going to bridge this gap, and we get 1 times 14, which is just 14, over 7 times 3. And I'm going to write out that 7 times 3. And then I'm going to look at that 14. I can rewrite that 14. In other words, I can factor it. Right, so I can rewrite 14 as 7 times 2, and this will be 7 times 2 over 7 times 3, and you'll notice the convenience there that when I factored that 14, all of a sudden we have a common factor in the top and the bottom that I can cancel out, and those would be the 7s there. So all that's left is 2 over 3. So that's how we did it with numbers, and now that we're in Algebra 2, we have to do the same thing with algebraic expressions, all right? But don't worry, it is the same exact process that we just did with the numbers. The only difference is now the numbers look like this, right? So one number is 2x minus 5, and it's inside of a set of parentheses. Another number is x plus 1. All right, not a big deal. It's a fraction just like the ones we dealt with. The operation is the same, so we're going to treat it the same. All right, so remember when we multiply, we just bridge the gap, right? We're going to bridge those together, and now these guys are being multiplied in the top and the bottom, so these become factors, and I might look to see if I have any common factors in the top and the bottom, and I do. I have an x plus 1 here, and an x plus 1 down here, so the x plus 1s will cancel out, and all that's left is 2x minus 5 in the top, and x minus 1 in the bottom. And that's it. See how easy that was? It was absolutely no different than what we did with the numbers. All right, we just bridged the gap, we looked for common factors, and then we canceled out common factors. Okay, so now let's try it with division. Okay, so remember, division is keep, flip, change, right? So I'm going to keep the first. So I'm just going to rewrite my fraction over here. I've got 2x minus 5 over x plus 1. I just kept my first. Didn't change anything there. Okay, then I'm going to flip the second, right? So now it's x plus 1 over 2x plus 5. Right, so I took the second fraction and we flipped it. Okay, that's what I got here, and then we're going to change the multiplication. Remember, with multiplication, we just bridge the gap, right, and put the multiplication sign in the top and the bottom just like that, and then we look for common factors here. Right, we got an x plus 1 and an x plus 1, so those are going to cancel, and then we have a 2x minus 5 and a 2x plus 5. Now you might be tempted to cancel those out, but having a minus here and a plus here makes those different factors, so we cannot cancel those out. So we've got 2x minus 5 in the top and 2x plus 5 in the bottom. And you can keep those in parentheses, and I would encourage you to do that because keeping things in the parentheses will eliminate the temptation for you to go through and like cancel the 2's and the x's. Remember, we can't cancel individual parts of these factors. We can only cancel the entire factor, which is everything inside of those parentheses. All right, so this would be our final result, our simplified result for both of these. All right, so you can see the operation is exactly the same. All we did here was we KFC'd, we keep, flip, change, just like we did with the numbers. Up here we bridge the gap, just like we did with the numbers. All right, so do not be intimidated by this. It's real simple, not hard at all. All right, let's try a few more, make sure we got this thing down. All right, so you'll notice here in our first example, they did not put parentheses around any of these things, so we can take care of that for them, right? We can put parentheses around all of these things, just like we're used to, okay? And then since I see multiplication here, I'm just going to bridge the gap, right? And then we know that there's multiplication in between these parentheses. So the individual parentheses become factors because they are things that are being multiplied, all right? And then I look for common factors that are in the top and the bottom of my fraction. So we have an x minus 5 in the top and an x minus 5 in the bottom. So those are going to cancel. And we have 4x plus 3 in the top. And in the bottom we have x plus 3. Okay, so this is my simplified rational expression after I multiply. You might be tempted to cancel some things out here, but remember, the entire parentheses has to cancel, so they have to be perfectly identical here, okay? You cannot cancel out two factors unless they are exactly the same. This one has a 4 in front of the x, this one doesn't, so you cannot cancel anything out here. Once you get to this stage, we are done, all right? The only thing we have to do is state our excluded values for our simplified expression here. All right, so remember, our excluded values are any values of x that make zeros in the bottom of the fraction. So when we multiply, we have to go back to our original expression before we canceled anything out. And you'll notice in the bottom we had an x minus 5, right? So a positive 5, right? 5 minus 5 would create a 0, so we don't want x to be a positive 5. And then here, a negative 3 plus 3 would create a 0, so we don't want x to be negative 3. Okay, so there's my simplified expression. There's my excluded values. Okay, let's try it again. Let's do this one. This one is division, so we're going to keep flip change, right? I'm going to keep the first, and just in case you're annoyed by the fact that there's no parentheses here like I am, go ahead and put parentheses on all of these, and we're going to keep that first again. So we've got x plus 2 over 9x minus 1. We're going to flip the second, right? So now 9x minus 1 goes to the top, right? And 2x plus 1 goes to the bottom. Okay? And then we change to multiplication. Keep, flip, change. Since this is multiplication, we can just bridge the gap here, right? Remember that there's multiplication between these two parentheses, and then we look for common factors, such as the 9x minus 1. Okay? So our final simplified result here is going to be x plus 2 over 2x plus 1. Okay, so there's my simplified expression. I need to go get my excluded values now. So I had two factors that were in the bottom. So I'm going to take 9x minus 1, and I'll set it equal to 0, and then solve. All right, so I added 1 to both sides. I get 9x equals 1, and then we'll divide by 9, right? So the 9's cancel, so then we find x equals 1/9. So I'm going to say x cannot equal 1/9, right? Because if I took that 1/9 and I plugged it in here, that would create a 0. And we got to do the same thing for this factor. So we're going to take 2x plus 1, set it equal to 0, and then we're going to subtract 1 from both sides. So we get 2x equals negative 1, and then we would say x equals negative 1 over 2, right? Because we would have to divide by 2 on both sides. All right, so x cannot equal 1/9, and it cannot equal 1/2. This is what we're looking for. All right. Let's do it again. Okay, so again, they didn't put this stuff in parentheses for us, not a problem. We can put parentheses around those ourselves. All right, now we're going to go through, this is multiplication, so we're just going to bridge the gap. And we're looking for common factors. So I notice I have 2m plus 3 and 3 plus 2m, and I know they're not perfectly identical, okay, but you can add in any order. So for instance, 3 plus 4 is the same thing as 4 plus 3, right? So the only thing that happened here is the 3 and the 2m are switched around in each of these factors, but they are the same, okay? So we can actually cancel those ones out. All right, so those go. And we have 7 plus 4m in the top, and in the bottom we have 3m minus 2. Okay, So this becomes our simplified expression, but then we need to find our excluded values of m. So we've got to take each of these factors and set them equal to 0. So for instance, I got to take 3m minus 2, set it equal to 0, and that'll tell me what value of m will create a 0. Right? So I draw my line. I'm going to add 2 to both sides. So those cancel. So I've got 3m equals 2, and then I would divide by 3. So we find that m equals 2/3, right? Which ironically means that m cannot equal 2/3, right? 2/3 is the value that'll create a 0 here. We don't want zeros in the bottom of our fractions. All right, we're going to do the same thing this time with 3 plus 2m. We'll set that one equal to 0 and solve that, right? So I'm going to start by subtracting 3 on both sides. 3's cancel. So now I've got 2m equals negative 3, and then we'll divide both sides by 2. Right, so m equals negative 3 over 2. That'll become my second excluded value. All right, last one here. It looks intimidating, but remember, it's already factored for us, so we don't have to do any factoring here. We'll look at some examples where we have to factor tomorrow. All right, and then, so what we're going to do here is we are going to keep the first. I'm going to say 5x minus 2 and 3x plus 1 over, and then notice that this is a 2x minus 3 squared, so I'm going to write that twice. So I'm going to say 2x minus 3 times 2x minus 3. Right, that's the same thing as 2x minus 3 squared. Now I'm going to flip the second. Right, so the bottom goes to the top, right? We're just making these two switch places. So I've got x minus 4 and 2x minus 3 in the top over 5x minus 2 and an x minus 4 in the bottom. And remember, we changed the multiplication. Right, so when we change the multiplication, we're just going to bridge the gap. Right, we can put that multiplication in the top and the bottom, and then look for common factors. So I've got a 5x minus 2 here. I've got 1 here, so those cancel. I've got a 3x plus 1. I do not have a 3x plus 1 at the bottom. I have an x minus 4. I have one of those here, so I can cancel those out. And then I have a 2x minus 3, so I'm going to cancel out this one and this one. And then I look at what I have left. I have a 3x plus 1 and a 2x minus 3. So this mess that we started with simplified to something much easier to work with, but we do need to take into account excluded values. Okay, so I'm going to solve for those real quick. Okay, so we're going to have 2x minus 3. So we go to the part after we keep flip change here. Okay, don't go back up here. Go here to where we keep flip changed, where we had everything multiplied, and look at your factors in the bottom. So I'm going to start with the 2x minus 3, and we'll set that equal to 0, and then solve. Right, so we would add 3 to both sides. We get 2x equals 3, then divide by 2. So we find that x equals 3 over 2. Right, so that's one of my excluded values. I do it again, right? 2x minus 3 again. I don't need to do 2x minus 3 again. Okay, I already found that excluded value here when we did it the first time. So I can fast forward to 5x minus 2. Right, so then we would add 2 to both sides. We find 5x equals 2, then divide by 5. All right, so 2/5 becomes another one. And the last one here, x minus 4 equals 0. If we add 4 to both sides, we find that x equals 4. That's a value that's going to create a 0 here, so 4 becomes an excluded value. There's my simplified result, along with its excluded values. Alright guys, that's it for today's video. Give the practice problems a try and let me know if you have questions in the Zoom chat. Have a great day.